So thank you very much. We are really looking to learn with you also and keen to learn about your approach to the data. So anytime when you want, you can start, Vladimir. Thank you.
Thank you, Simao. I will start from visiting the case which Zdenek mentioned and Alla commented. It's 1,4-dichlorobutane. If you see my screen, do you see?
No.
There is a thermodata engine, is software we develop, and now it is its free public version is available, and I hope it will be available forever, and it will be given additional functionality every year. So the evaluated result and its uncertainty strongly depends on the amount of available information. Zdenek showed an excellent approach what you can do having limited information, and if you collect all data which contribute to equation of state, you may do more consistency checks. You can derive properties using thermodynamic relations, and this is what we do in thermodata engine. I don't try to compete with Zdenek's approach because I don't claim we are close to perfection. I'm aware of any deficiencies, and it's possible to improve infinitely. So this is not an equation of state, it is a quasi-equation of state. It is a presentation of different properties by separate equations, and consistency is enforced as fitting constraints, and it is not exact in contrast to equation of state. And I can show an example for vaporization enthalpy. Blue line is vaporization enthalpy presented by separate equation, which is, I believe, Watson equation. Green line is same quantity derived from vapor pressure, liquid density, and virial equation of state, and black points are experimental data. So the consistency is pretty good, but not exact. And now let's switch to vapor pressure.
Vladimir, are you listening?
Yes.
Try to enlarge these tables and graphs because, or do some kind of in order to, because here it's very small and people are not reading so well.
I'm sorry. These plots will be available only to give a qualitative presentation, because even if what I can do, I can magnify it, but the size of the point remains the same. Is it better?
Yes.
Okay. So, sorry, because you have a different perception. So normal boiling point in this case is kind of reverse calculation from vapor pressure equation at pressure which is equal to 1 atmosphere. And if you consider data in that area, you see that data reported as normal boiling points, they are of low quality, and data set of vapor pressure is apparently of better quality. And actually, I knew the first author, and I know that this laboratory is a very reliable laboratory. Sorry, I'm lost a little bit because of this magnification. Let me see. Sorry, I don't know if it's probably it's not well visible. Okay, so if we go to evaluate the data, the normal boiling temperature, which Alla already reported, is 428.24 plus minus 0.08 Kelvin from our evaluation. Again, the uncertainty is the quantity very uncertain itself by its nature, and I would not distinguish uncertainties which are similar. I would just quantify uncertainties stepwise, something like 0.01, 0.11, and so on. Okay, and finally, I will show deviation plot. And this is the best data set. You see it. And to be honest, the automated procedure in TD was unable to remove recently published worse data, which pulled the equation a little bit at low temperatures. And I just removed those data by hand and repeated these evaluations. So the Zdenek's approach may be very useful addition to our automated methods. And I would be happy to collaborate with him, his team, and anyone working in this area. Okay, and now I'll switch to the presentation. We already had workshop, I believe, dedicated to uncertainties of initial data, experimental data. And now I'm focused on uncertainties of final values. And how I define final values, the values which are used in applications. I have troubles with definitions, and maybe I don't know something, and I will appreciate if you amend my knowledge. This kind of data are frequently called either recommended data or evaluated data. But to me, it seems ambiguous or not appropriate in this case. Because evaluated data is ambiguous because it may be just raw data with re-evaluated reliability. And recommended data, it may have some legal meaning. For example, in IUPAC, there are technical reports, there are recommendations, and if we are talking about recommendation, it's a question what is legal status and who recommends this data, and then again, what is the basis of recommendation? Because recommendation can be based on incomplete data, on biased evaluation. So I define final values, the values which are used in applications, such as process simulation by chemical engineers or data for safety information. Okay, and then next slide. Who needs uncertainty evaluation and why? First question is who needs data? Again, I distinguish raw data, the data obtained in measurements and sometimes precise calculations nowadays. And final data are usually presented as models because unless they are single values such as critical properties, because for any application you may need values at any conditions, and the best probably way is to present data as equations. It's better than interpolation in tables of calculated values. And I would say we don't need final values. We produce them for our customers. Our customers need them, and we may be interested in final values produced by others for comparison reasons and for mutual corroboration or consistency checks. And I encourage if you say maybe in chat what is your role here. My understanding is that experimentalists produce raw data, then theoreticians they produce something which is close to what I define as final values, but you may use raw data as source data in some cases, or in other cases, if predictions are pure theoretical prediction for verification. And finally, engineers use and other users for final target application. And also, it's a question who needs uncertainties and why. Experimentalists, maybe they have some intrinsic motivation to evaluate how accurate and reliable their measurements are. Theoreticians may want to account for reliability of data they use as source data or for comparison. And people who really may need uncertainties are final users, but let's consider how they use it. Again, I would appreciate if you comment to what extent you need data and data uncertainties. Industrial use of uncertainties. The most advanced approach is sensitivity analysis, but it is not used in mass scale. I heard a couple of conference presentations, but I could not easily find a relevant publication. The one which I'm showing here is not exactly what I mean. It means what parameters influence the process which is simulated. But my context is what variation in data cause the most significant effect on final process simulation results. So process simulators don't involve this on a routine basis, but these developments are being done, and I may not be aware of the most recent developments, and some of you may have commercial process simulators and may be familiar with the options. Usually, chemical engineers use data reliability categories, and big companies have their own definitions, such as ABC, for example, and it's a kind of qualitative propagation of this definition to evaluation of the reliability of final process design. And to conclude, as they never know for sure how reliable the data and their simulation is, they do over design in industry, and there are some established principles of over design. So before evaluating the uncertainties, it's necessary to get the data. And my experience is that search and access of property data is not easy. Existing actually commercial data search and access systems are mostly targeted to present patent information, biomedical, synthetic, but not property data. And if you have a good and unbiased collection of data on any question, it's a lot of work and good luck. And my feeling is that the effectivity of existing chemical information search systems is comparable to just Google search now. But if you have different experience, again, I would appreciate your feedback. Please use chat or just talk during discussion. And the question about completeness, and unfortunately, a lot of data produced in the public domain for public funds, they are lost forever because of not properly reporting. And that is why we had a good reporting practice initiative, which was an IPAC project, and representative of industry and experts expressed what should be published after publicly funded research. But it's also question if quality of publication correlates with quality of data. Maybe data which are not properly published do not deserve. That's not true. Frequently, very good measurements were lost forever. So my impression is that the research cycle, which is application, granting, publication, and then citations, it is quite disconnected from users who are also sponsors and taxpayers. And I try to find a solution, unfortunately, without big success, but we'll continue some efforts, and I will talk about that a bit later. Next, to evaluate uncertainties of final values, we need to evaluate uncertainties of reported data. We had another workshop on that, and I'll go through it very briefly about our approach. Our traditional approach was based on nature of chemicals, purities, properties, methods, and we had recommendations in compiler's manual, and I believe we can share this manual with interested people. Just contact us. And it was implemented in guided data capture, but unfortunately, it is far from reality because it gives estimation for properly done measurements and completely and correctly reported in all details. Unfortunately, this is not the case in many, if not majority, publications nowadays, and we need different approaches. So we published our article on evaluation of data reliability. We called validation, but my colleague Kirk Nordstrom from United States Geology Survey strongly opposed it. He published another article on corroboration of data in geochemical domain. And to be honest, what we call validation of data, it's actually invalidation. We reveal all inconsistencies, all factors contributing to errors and uncertainties, and the more we know, the larger are our uncertainty expectations. And as I mentioned, because frequently the errors are much larger than any reasonable errors expected, it's necessary to do some detective job. And the questions are here. First of all, if the reporting honest, and what is the performance shown by the author and the laboratory, how they follow protocols, how they disclose all necessary details. And here is an example from the previously shown publication on data validation. It's a quite trivial thing, solubility of glucose in water, and you see two lines, two trends. Black points are stable phase equilibria reported in many publications, and there are several publications shown in red and orange, and the history is described in that data validation article. It looks like an error converting mole and mass fractions was made in one reference book, and then some people claimed consistency with those results and published their results several times. I don't understand how they can obtain results consistent with incorrectly reported data in that book, but this is the situation. And if you just open any random article and just blindly trust it, you may be in trouble. So we've done this detective job, and Earl showed you list of sources. There is one source from 2007, one from 2014, and 3 separate recent publication by same authors, third group of authors, and first publication and in red, and 3 most recent publications in black. They are in quite a good consistency, and 2014 publication deviates. And my question was, were the authors of more recent publications aware of previous publications or not? We checked it, and the authors of the most recent publications cited both of previous publications, and they were consistent with one of them. So I can guess that they provided their unbiased results, not affected by any expectation. And let's talk a little bit about 2014. I'm sorry.
Vladimir, you need to reconnect because it's your VPN. Excuse me, just if 1 more minute for Vladimir to connect to resources.
Thank you, Alla.
Sorry about interruption. Do you see me? Do you hear me?
Yes.
Do you see my screen?
Yes.
Okay. So let's switch to presentation. 2014 publication. If we take a look at other publication by the same authors, we see terrible results. There is another system, I believe, glutaric acid plus water, a bit different system. But you see on the left side, the red dots are very inconsistent with all other data and with any modeling. And but the good thing is that the authors apparently honestly reported their erroneous data, and it was published, and it is evident that huge inconsistency exists, but it was still published. So my conclusion is that unfortunately in many, if not majority of cases, scientific journals are becoming in reliability similar to social networks now. Whatever can be published there, whatever can be claimed, and if anyone catches this mistake, the authors can say, I'm sorry, I just received these results. And the additional thing, dark matter. I can say very little about it, but the article published in 2014, it went through 3 at least cycles of review and 1 rejection. And many data sets were heavily modified during this review and resubmission process. Unfortunately, because of the privacy requirements, everything is hidden. And if you open any publication, you never know what happened to it and how the data were modified, what information was hidden. So the only way to make a guess, unless you was the designated reviewer, is just to analyze performance of those authors or laboratories. And I believe it's politically incorrect to maintain blacklists, so we should just presume any publication erroneous unless it came from laboratory and researchers with established reliable research record. Okay, now finally, data analysis and uncertainty evaluation. One thing I would do was checking how the data deviate from ideal behavior. And I used ideal mixing model with together with enthalpy and the temperature of fusion. On the left side, we have ideal solution curve. On the right side, you see another almost ideal solution curve, which is original unifac with only combinatorial contribution. You see that combinatorial contribution from unifac perfectly describes these data, and the data do not deviate from ideality too much. Then let's compare two similar systems. And there are similar plots for solubility of butane dioic acid, pentane dioic acid, and hexane dioic acid in acetic acid. And you see the situation is a bit more complex. The upper part is just ideal solution. The lower part is combinatorial solution. But the scales are a bit different, and all data on the left picture, the composition range is to the left of the composition range of the central picture. The right picture has more or less, actually also it shows left side. Based on that, we cannot say that correlation would provide any additional useful judgment. And finally, if we just compare the values, this is the plot generated with thermodata engine. And I can show you. Thermodata engine allows communication and manipulation of data. And I hope that it will be more and more available to the public. I will show you how you can get it a bit later. And this is another presentation, which is unfortunately heavily underused. If you just present logarithm of mole fraction ratio instead of mole fraction, you can do the same with mass fraction. You will see much better picture where also high concentrations and low concentrations are revealed much better. So it's C4, C5, and C6. It's hard to say whether it should be any linear relation, but at least C5 is between C4 and C6, and the temperature trend is also consistent in the series. Then for assessing raw data uncertainties, if you if you need to know very precise uncertainty, it can be possible only if you don't need this data. If you can figure out the true value some other way. It's like well-known phrase, a bank is a place that will lend you money if you can prove that you don't need it. So you can know uncertainty of the value if you don't need the value. But what we can do is approaching the true uncertainties from both sides. Lower bound, what I mentioned, revealing all extents of inconsistency, and upper bound is a bit more difficult. Probably it's pretty easy in case of well-studied systems such as, for example, ethanol water or ethanol water solution, where we are pretty sure we know the values very close to true values. But otherwise, we need to find something that provides maybe large and conservative uncertainty, but we may be sure that real error will not exceed it. It's not easy. And speaking about raw data uncertainties, it depends on method and many details. And analyzing the report is labor intensive, and we could spend whole our life just analyzing this case and the related data. I would touch only one of experimental methods. It was not used in this case, but frequently solubilities are measured with DSC, and people are in rush to produce as much as many as possible data sets and publications, and unfortunately, the correct technique is frequently lost. There are well-known recommendations published decades ago how to interpret complex events in DSC. And there are basically two approaches. One approach is extrapolation to zero heating rate, and another approach is shown here is using sophisticated calibration. Unfortunately, the signal on the lower upper part, which is obtained from DSC devices, it is not temperature, it is temperature measured and modified in black box of producers' software, and they don't disclose how they convert the signal. So it becomes even more uncertain, but I would like to make a small contribution to this area. Though numeric simulation of these processes have been done several times, I would like to repeat it specifically, showing how different ways of calibration affect the results and justify this proposed way of calibration. And model uncertainties, in addition to our knowledge about raw data uncertainties, we add deviations from models, and they may be caused by data errors, but they can be also caused by model bias and overfitting. And also, evaluating model uncertainties, we have problem of extrapolation. I will touch it a little bit later. And major approaches known to me are so-called probabilistic and Bayesian. Probabilistic is when we build one single model which is most probable and evaluate its uncertainty. And Bayesian, to my best knowledge, is when we build a collection of models and we rank them quantitatively to according to probability to be true, and then we calculate the target value using all these equations with appropriate weights, and then we have distribution of target value. In my opinion, it would be probably the best way to evaluate extrapolation errors, but limitation of this method, to my knowledge, is that it is based on our knowledge of raw data uncertainties. And the things which are revealed from scatter, they don't contribute to those uncertainties. Of course, I may be wrong, and please correct me if I'm wrong. And the ways uncertainties are calculated can be either, to my best knowledge, covariance matrix, or like Monte Carlo when you do multiple calculations and then analyze possible outcomes. In thermodata engine, we tried basically everything, but the only production way is covariance because it is simpler, faster. The efficiency of covariance is that it is limited to second order correlation between parameters, and in case of strongly correlated parameters and large uncertainties, covariance produce very unrealistic results. So we apply some empirical adjustments. I will talk about them. And the method is in the probably most convenient way described in famous book Numeric Recipes, and the codes are also given there. We modified this method. We combined both data and known believed data uncertainties and curve deviations, and we limit the amount of random error. So if you increase data set, TDE procedures stop decreasing uncertainty at some point, just assuming some plain level of systematic uncertainties. And in case of multi-parameter equations, just straight covariance matrix, at least in our implementation, gives wild results which produce splashes in some state variables spots. So we also use iterative adjustment, which is described in this publication, and also beauty of covariance method is that you can select what you consider as parameters for covariance, even if they are constants or externally brought values. You can make them just variables in calculation of covariance matrix. And when we apply an RTL equation to this mixture and just use the existing procedure, we have these results. You see this splash in calculated uncertainties calculated from covariance matrix on the lower right part. But basically, this is consistent with data scatter, which is about 2 Kelvin, and there is some shrinking this range because of number of evaluations. They are considered as independent in covariance method, but this is not true within each data set, and this is probably limitation. So it's possible to improve, and I would be happy to collaborate. Unfortunately, we are a small group and doing so much things that we can go in depth to only limited extent. So I would be happy to find collaboration opportunities. And I promised a demo. So if we open this mixture in Thermodata engine, then apply an RTL equation, and because only solubility data and solubility of only one compound is available, TDE proposes to symmetrize this equation. That means to use same interaction parameters from both sides. We can override this. The user has a freedom, and when we fit it, we have this equation. In this case, a limitation is we don't consider uncertainty of melting temperature and melting enthalpy. It is possible to do this development, but again, we need time and resources for everything, and we try to prioritize what we do. If anyone is interested in collaboration, we would be happy. Okay, so, and finally, when you have final values and when you have their evaluated uncertainties, then question is how can you double check them? How can you verify? And one of the methods I always use, I try to compare possible alternatives. And here is a fragment of presentation made a few years ago. It's about Kirkwood-Buff integrals. If they are derived from experimental data, they are kind of second derivative, and they are very sensitive to any experimental errors, and model bias, overfitting. And you see here the results for the same mixture with quite significant non-ideality acetone plus hexane derived from equation of state and from separate equations, NRTL plus equations for density. You see they are pretty much different, and if in this case I would consider uncertainties not smaller than difference between these two models, unless I could find one of them obviously erroneous. So my proposal in this case was avoiding using Kirkwood-Buff integrals derived from experimental data. Instead, if Kirkwood-Buff integrals are calculated theoretically, then do next step, calculate thermodynamic properties, and then directly compare those properties to existing data. It could be probably more adequate comparison. Now about availability of thermodata engine. Our thermodynamic research center is belong to a government agency, and we also have customers and sponsors, and we need to balance our output between public domain and output available for customers on subscription or purchase basis. It is not easy to maintain the right balance. We are trying to find it, and as part of these efforts, I would like to release thermodata engine and its functionality for the community. Presently, it gives access to data in our public data domain. Our main database contains over 9 million data points, and the public domain contains 2 million, and our data capture operation is basically supported by our customers. But of course, it would be good to make data better available to the community. And my idea is that I would like to motivate experimentalists to report data in machine readable formats, so they would immediately be added to public data domain, become available to the community. And of course, all users would benefit from that, and the authors would also benefit because their data would be easily accessible, discoverable, and what is immediate impact? It's only number of citations. It could increase number of citations and chances to obtain another grant. And then related IUPAC projects. We are running a few, or completed few projects. One on reference systems for phase equilibria, solid liquid, liquid liquid, and vapor liquid. 2 reports have been published, and one is in the preparation stage. Good reporting practice project has been completed, and now it's a difficult question how to make it working, because the recommendation exists what users expect from publicly funded research, and experts also support these recommendations, but how to motivate researchers and publishers and funding agencies to follow that and make research results available to the community rather than just wasting them. As part of these efforts, we have a project on review and support, providing tools in support of reviewers' job to catch and address most common deficiencies known in publications of property data. And we are planning at least one other project in the future. sharing unsolved changes in thermodynamics, which may encourage some researchers to do research to solve them, or use as supporting kind of support when submitting proposals, if they just match existing changes and the proposals. And I would like maybe the final project in this series would be project related to machine-readable data publication. So now I'm finished my presentation, and I would appreciate feedback and discussion. Thank you very much. And maybe Alla wants to say a few words before that.
Thank you. You covered all the aspects, so we discussed. Thank you.
Oh, it is working. So thank you very much, Vladimir and Alla, for this contribution. Before I give the mic to others to ask questions, I just had a reminiscence when I saw the data that were inconsistent, the correct data, and then the incorrect data that you showed, Vladimir, where people have consistently been in good agreement with the wrong literature. In my country, in our country, in Czechia, we say this is multiplied by a Bulgarian constant, because that's what we do when we think someone has done a good job, and then we want to match it. So, these authors may have done just that. So, are there questions?
Just Magdalena, just one quick comment. So this is not the only case when we observe that authors trying to match data to erroneous reference data.
We retain a lot of dark matter information. Unfortunately, we cannot disclose it.
Okay. So,
Vladimir, you talked about the public database and authors uploading their data into that, which makes it available. And there's an issue around that, which is something to do with how we advise authors. Journals live off citations. So if it's published in a journal and is uploaded to the database, then authors very commonly will say, well, we got this from the database. And so the editors of journals, or the journals that people edit, lose out. And since publishers are counting the value of journals comes from the number of citations that they get, it's actually not in the best interests of journals to support this. And so there needs to be a way of ensuring that the citations go back to they may be a dual citation, it may be the journal and the database both get cited, but there has to be a way of organizing this or instructing authors about this so that nobody loses out from what is a good idea.
Thank you. It's a very good and valid point. And there are several aspects. First of all, I would mention that many publishers now encourage authors to use different repositories to submit the data. And in this respect, we can be considered as one of possible repository. Unfortunately, none of the publishers ever recommended us as a repository. I believe we provide a bit more than most of other repositories. We provide convenient search and access. So this problem is general, not only specific to our database. It's also a question about all other repositories. Next, journal editors. Of course, it's some additional job. They are in charge to comment and require the authors to cite original sources instead of black boxes of secondary publication. Then these data, machine readable data files, they can be made also supplements to original publications. In this case, users can consume data just from journal websites. Our additional convenience is that we provide tools for data access, visualization, maybe data analysis in the future, and also you can access all data for selected compound or mixture. And of course, we should strongly recommend all users of our resource to cite original publications. And if you take a look at our tools and resources, and if you have any suggestions how we can improve this communication to users of our resources, we would appreciate your feedback, and we would try to do our best to implement your suggestions.
I can add a few comments, Earl. So first of all, so the convenience of such database as what Vladimir described is the data are structured and easy to find. So that is a convenience for those who need data. So, but on the other hand, you mentioned this citation. So the idea I can suggest is multiple journals have some automatic check-in for example, plagiarism or something like that. Similar check can be implemented if a citation on a database like webbook or our database is found. So the immediate feedback to the authors, make sure that you cite the original resource. It can be automatically done within the journal like it's done for plagiarism test.
Also, sorry, do you still see my screen? Let's do,
no. We don't see your screen. Sorry.
Okay, let me share it again. So right now, do you see?
Yes.
I'm running this free public TD, and let's do a risk experiment. I did not do that before our meeting. What if we check what we have in the public domain for this mixture? Oh, and second component. Unfortunately, we don't have those data because.
No. Can you upload from?
Oh, sorry. My mistake. We need to go through another step. Import from our data archive. So now we are communicating to our server. Yes, we do have something. So of those data, we have three data sets in the public domain. And if we plot them, we see that 2014 data set, and some uncertainties claimed by authors are huge. And in some cases, you don't see uncertainties because this presently TD shows combined uncertainties where everything is propagated. And if data are reported as temperature as function of composition or composition as function of temperature, there is no obvious transformation. And that is why not all uncertainties are shown. Again, it needs additional development. It should be coherent with maximum likelihood principle when independent uncertainties of all state variables are maintained, and combined uncertainty can be generated for any of the properties. Okay, thank you. That was my short demo of what we presently have in the public domain.
Okay, thank you very much. Any more questions? Okay. Volk.
Arno Trippola from Aalto University. I was just thinking about your problem, and could you consider that once per year you published which parameters are downloaded and how many times with reference? That will indicate how much the database is used and which articles are good or considered worth of downloading, or the data, I mean.
Could you please clarify the question? So you're asking about the downloads from the database?
I mean that if we have that kind of database where you can download the data, and if it's away from the journals itself, one idea is that the database.
Could you please exchange the mic because we're having some.
So this has to be very difficult succession. Okay, so we have a box where is some data collected, or authors are sending them public data, and the journals doesn't like it because they don't get the reference how many times it has been used. So
Okay. Yes, just keep changing.
So maybe I shouldn't success at all.
No, please, please.
Microphones are against me. So if this collection of public database, which is referring, is sending a report, for example, once a year, which data has been retrieved there with a reference. For example, if I send my article there and the parameters are retrieved 5 times, it will indicate that this article has been, the parameters from this article has been downloaded 5 times.
Well, hopefully I understand the question, and it is a good point, but our retrieval system is not reference based, centered. It is system centered, and it can be counted how many each compound or mixture has been queried. And second, whether we can make this information public, it's a legal question, and I cannot answer this question now.
Unfortunately, we as a government agency are not allowed to share this information.
No, we cannot share any information about and even access information about privacy of visitors who visit the website, but statistics about querying particular information. It is not obviously restricted, but I cannot say for sure what we cannot disclose.
Okay, thank you for the
But we got your point. It's a good question, and it's a big problem to us also, because we make conclusions which data are good, which data are erroneous, and as a previous speaker mentioned, criticizing bad data just gives them additional citation. And also, I would like to take this opportunity to again appreciate Zdenek Wagner's job. And as I mentioned, we sometimes are unable to automatically reject data which make evaluation worse. And I would appreciate if we can collaborate and automate the process of better outlier rejection.
Okay, so I don't see any more questions. So it's okay. No, Wolfgang decided, yeah, because we're getting near the first hour of the second part. So I will give over to Simon again.
Thank you very much.
We want to say thanks to you and okay. Thank you, dear Vladimir and Alla, for being present here today also and sharing your experience.